I told you that no electricity is coming over here, so this was interrupted. Okay. At the point A, the direction of motion is in the western direction. At point B, it is a motion in the south. At point C, it's east. At point D, direction of motion is the arrow direction north. And at the point E, it is direction of motion in the west, south, or southwest. Got it? So whenever this is connected with this point, and this is called as the centripetal force. A force acted towards the center is called the centripetal force. When that fellow, that father was moving his hands like this to remove the birds and cattle from his field, at that time he leaves one hand or one part of the rope and the stone goes perpendicular towards the bird, the destroying cattle. The vector drawn at that particular point. And what is the vector? Vector is nothing but having the magnitude and the direction of a body. Direction at these 4 points A, B, C, D, and the A it was west, at B it was south, at C it was east, and at D it was northern condition. At E it was southwest. The magnitude of the arrow length tells about the velocity of that object. If the length of the arrow is bigger, the velocity is bigger. If the length of the object is slow or very, velocity is also small. Higher the velocity, higher the magnitude, and higher the displacement will occur. Okay, and that much far that stone will fall. So, students, you have come to know about the inertia, the state of motion in a linear condition, and inertia of rest, inertia of motion, and inertia of a circular object. So, in his first law, the Newton used it, Newton's first law, a body is unless we are not applying any external force on it, internal power through which it is connected. These are the first law of motion or the laws of inertia. Now, in the laws of inertia, that is an accordance with conservation of energy. Energy can neither be created nor be destroyed, but its one form can be changed into the other form. Energy can neither be created nor be destroyed, but its one form can be changed into the other form. If I am having 1000 rupees in my pocket and I purchase something, I am in a loss of 1000 rupees because I am giving it to that person. But the person who is taking that 1000 rupees is gaining, he is in a profit of 1000 rupees. Means there is no loss, there is no profit, but it is in a constant motion. Energy can neither be created nor be destroyed, but its one form can be changed to the other form. A state of rest or the state of motion is nothing but it. In conservation of momentum, momentum can neither be created nor be destroyed, but its one form can be changed to the other form. Conservation of mass, mass cannot be created nor be destroyed, but its one form can be changed to the other form. Conservation of energy, energy can neither be created nor be destroyed, but its one form can be changed to the other form. This is just like a mantra. With everything, wherever conservation words comes, neither be created nor be destroyed. Neither be created nor be destroyed. One form can be changed to the other form, one form can. Work was equal to force into displacement. Similarly, if the work is conserved, then the force and displacement will also be conserved. At this condition, W1 will be F1 S1, W2 will be F2 S2, 3 will be F3 S3, If they all are being taken together, then F1 S1 is equal to F2 S2 is equal to F3 S3 up to the dot Fn Sn Fn Sn. This is only an example. This is not a truth. Why this is an example? Because as you are now grown up, everywhere you see it. P1 is equal to P1 V1 is equal to P2 V2. What is this? Pressure and volume remains constant. Have you heard in the chemistry? P1 V1 is equal to P2 V2. It means if P1 V1 is equal to P2 V2, then it is equal to P3 V3. It means it is equal to P4 V4. It means it is equal to P5 V5. It means it is equal to Pn Vn up to the n number. It means Pv is equal to constant. If it is a constant, it means this is a conservation law. If this is a conservation law, inertia is nothing but a conservation law. Means an object in a state of rest, it will remain in rest until unless we are not applying any external force in it. If a body is in a motion, it will remain always in state of motion until unless we are not applying any external force on it. Everywhere is the conservation principle. So in the kinematics, this is very important concept. Now, but I take another pen. Now, what happens? The word inertia, inertia of motion, and this. From how you will understand the inertia. Suppose this is a small boy. This is a small boy. And this is a bigger boy. It means, or I have to rub it out. As it is raining heavily, very badly outside, so my duster is totally wet. This is not wet by calling, but this is wet by rainwater. So it will take a moment to dry out. Then I will run my this pen on the board. Otherwise, it will be lighter. So you have to wait a moment. What I am going to say, inertia, the word inertia, constantly I am using this word. And the inertia, if there is a car, if there is a truck, if there is a train, if there is a aeroplane. If there is an aeroplane, if there is a car, if there is a truck, the mass of an object is higher in case of a truck with respect to the car. In case of train, with respect to the truck. In case of the aeroplane, with respect to the train. So whenever mass increases, inertia increases. It means if a body is having a mass of 10 kilograms and of another body, this is M1, another body having the mass M2 is equal to 100 kilograms. The inertia of the body having the mass M2 will always be more than or in comparison with the body having the inert mass of 10 kilograms. But I am using the word mass over here. I am not using the word weight. There is a slight difference between both these two, but there is a vast difference in case of this chapter or the concept of inertia, a law of motion. When we will use the word weight. What is the weight? W. W is equal to M into G. When the mass is multiplied with the gravitational force, then this becomes weight. But friends, Very important concept. Weight and mass. You will understand it very easily and very interesting also. When a person goes in a space, an astronaut goes in space, there his mass does not change, but its weight becomes zero. This is a condition of weight. Because in the formula of the weight, I have used the word mass into gravity. Gravity becomes zero, and when gravity becomes zero, anything multiplied with zero becomes zero. So in the space of the universe, the weight of an object becomes zero because the gravity becomes zero. So this much importance is here of G. If G is there, then mass becomes weight. If G is not there, mass remains mass. So if teacher asks you a question, what's your weight? He is asking you both your mass and the gravitational pull together. If you say this is 60 kilogram, then what is your approximately mass? It means divided by 9.8 or 10, it is equal to 6 kilogram. 6 kilogram is the mass. And what is that mass? That mass is the total number of particles compacted in your body. The sum of all those particles united together and when weighted, and it is equal to your mass. Number of the particles present in your body is your mass. It does not change anywhere in the world, but weight changes. So therefore, in inertia, mass is an important concept, not the weight. So inertia of an object having the lesser mass, not weight, having the lesser mass has the less magnitude. And the inertia of an object having the more mass, having the more magnitude. Magnitude of inertia, magnitude of position, magnitude of direction. Got it? It means when you push a cycle, you can easily push because its mass is less. When you push a scooter, you take some extra power because its mass is more than the mass of the cycle. But when you push a truck, it is not possible for you to push it alone. You call 3 or 4 strong persons, which are because their mass is very less. So mass is a very important concept in the inertial position. So to understand the inertia, the mass concept is also important. So we will use mass in all the inertial conditions, but we will never use weight. In this one, in the law of motion, when the mass is over there, an important condition, in a state of rest, inertia of rest, this is an object having mass. As this mass, how much force you have to apply to keep it in motion or bring it into a motion condition? That much force you have to apply as much as mass this body is having. Correct? Then a question arises. But what the hell gravitational force is doing over there? Then gravitational force is creating a frictional resistance. Mass is giving you a resistance. But the G helps you to give an extra resistance. We will study it later on. This is a higher concept. Anyway, this mass is important. When this mass starts moving, this is the resting condition, rest, inertia of rest. When this mass starts moving with the velocity of v, the mass multiplied with the v, that becomes mass into velocity. It is now displayed by a small letter, small p. This is now known as the momentum. Mass into velocity is known as the momentum. Now in physics, see, we learned distance, meter, unit, displacement, meter unit speed or velocity meter per second. Correct? Now we are studying momentum. Momentum means mass into velocity, mass in kilogram, velocity meter per second, kilogram meter per second. The unit of momentum becomes kilogram meter per second. Very important part. When your teacher slaps on your face, what happens? What is important? Have you seen few female teachers slaps on the face of any student? How? You are naughty boy, you are naughty boy, you are naughty boy. See, the velocity C, although she is having a mass in her palm, but the velocity is very less. Naughty boy, naughty boy. When the mass and velocity, it means the momentum is very less on your face. But if a male teacher comes, he gives a slap, he gives a velocity, and the mass is always there, and tap. I'm not slap on my face, okay? Don't think that I'm going to slap my face this time, because that time I was slapping very small. So, he will slap on your face, tap. What happens? High velocity and mass there, high momentum knocks you. My God, what happened? It starts in the daytime. This is the terror of the teacher. So you will say the mass into velocity, momentum. Yeah. Now, some of the students are very important, very intelligent. What they say? Oh, this is not moment, yaar. The teacher slap on your face is not a momentum. And what is this? If this is not a momentum, then it's an impulse. What is the impulse? The force into time is called impulse. Means how much longer time he has taken on your face is impulse. Oh, it was a great impulse, yeah. It was a great impulse. Because he took under consideration the time also. In the mass and velocity, there is no time. For how long the hand was there on your face? It is not mentioned. The time is missing out here. But in the impulse, force into time, for how long time this force was active is important. Got it? So I will teach you it later on. Initially, stepwise, with time became speed or velocity, having a meter per second. Now it converted into the momentum. Momentum is equal to mass into velocity. Means mass for velocity. Now this velocity, distance used in velocity, velocity used in momentum. Momentum is equal to mass into velocity, kilogram meter per second. Okay. Now, if we are dividing both the sides, although this is not topic, but I am just playing. Dividing both sides by time, denominator. Now this time is a part of both mass and velocity. I am segregating them. Segregating means I am splitting it. Mass over here and velocity upon time here. Correct? Upper part will multiply with the upper part and the lower part is intact. So velocity upon time, rate of change of velocity is called acceleration. Put it over here. Mass into acceleration. What is this? Mass into acceleration is a Newton's second law. That is called as the force. If this is a force, then momentum upon time, rate of change of momentum is called the force. So you will see, now you can answer. There is no need to use the word impulse while you were getting a slap on your face by your teacher. Then now it is a better word to say how much force you got, how much momentum upon time. The momentum mass into velocity is there, divided by time. Time is also over there. Means how force was very big here. टीचर ने किस फोर्स से हमारा बिड़ू चेहरा सुझा दिया यार. Now the force is defining you about the mass of the teacher's hand, about the velocity he has given to his hand, about the time he has used to slap on your face. So the concept is very clear of the force. If you use the word force, no need to be confused about the force. This is initially I was teaching you the first law of motion. Now this is the second law of motion. Okay, today you learn two motions of the Newton's two laws. What law? The first law of Newton's first law and Newton's second law. What is the Newton's second law? Mass into acceleration is called force. Okay, mass into acceleration is force. I have to stop it today. It is raining heavily and my laptop is showing me 2% battery. My mobile is also showing how much I took a half an hour lecture and the connection was disconnected and this time 23.35. Okay, see you tomorrow. Tomorrow I will teach you biology. Get ready for that. Okay, and this team, have a nice time. Don't fight together. Enjoy my lecture. Bye. Any problem? Comment on my mobile number I had given over there. Bye.